So earlier on this unit, we just added. You know that when you're adding fractions, you need a common denominator, then you can add the tops. We multiplied and divided. We used our fraction rules for multiplying, which meant you multiply the tops, you multiply the bottoms. But before we multiplied things out completely, we factored to see if things simplified. Same thing with dividing. We factored to see if things simplified. So we are now getting into solving equations. And in solving equations, it's going to be a mix of adding, subtracting, multiplying, and dividing. It's going to be a mix of all of those things. But one of the strategies that we are going to use is this idea of we can get a common denominator, then what you do to one side of the equation, you do to the other. You can multiply and simplify. There are a couple of places where we're going to run into some like little things we have to be careful with, but for the most part, that is what we're going to do. So for part A, I look at my denominators. I have a 2x, a 5, and a 10x. As far as numbers go between the three, 10 would be the lowest one. So this one needs to be multiplied by 5 and 5. That one needs to be multiplied by 2 and 2. And as far as the variables go, there's just an x, but the second one doesn't have an x. So that second one is going to be multiplied by the 2 and an x. That will give me 5 over 10x minus 4x over 10x equals, and the last one didn't change, 1 over 10x. Now what we are going to do next is we are going to say, well, what you do to one side of the equation, you do to the other side of the equation. So if I multiply both sides of the equation by 10x, something wonderful is going to happen. The first term, when it multiplies by 10x, will cancel out the 10x. The second one will cancel out the 10x. The third one will multiply and cancel out the 10x, and we've gotten rid of all of our fractions. Our equation is now 5 minus 4x equals 1. We have some like terms. I can move the 5 over. Then I can divide by negative 4. And x is equal to 1. Another thing that we are going to do with solving equations, which is very important, is we will always list our non-permissible values. In this case, are we ever dividing? Yes. Is there any possibility of x that would make us divide by 0? Yes. In fact, what can't x equal? Well, if x is 0, then I divide by 0. So x can't equal 0. And the last thing we're always going to do in a solving equation is check that one of our answers isn't actually something that's not allowed. Because if you solve an equation and you say x is equal to 0, and then someone says, but 0 is not allowed, then it's actually not a solution. Because you can't have a solution being something that's not allowed. Trying to, yeah, can't think of any appropriate, good, real-life problems. Right? Yeah, well, something totally stupid, but okay? Students are thirsty. That's the problem. You want to get them something to drink. That would be a solution. What's not allowed? Bringing in beer. So my students were thirsty. I was worried about it, so I brought in beer. That would be like not a solution. That would probably cause problems. Okay? Because we have something that's not allowed in the school, and then it was proposed as the solution. There we go. Okay. Let's do B. Can I erase part A? Is everybody good on part A? So did you see the strategy? We like to write down strategies. 1. is what we did. We got a common denominator, and then we multiplied to get rid of the fractions. And they got rid of really simple. And I think as far as technique goes, I mean, there's other similar techniques that will do the same thing, but this technique keeps it the simplest so that you don't make mistakes, right? There are some people that say, find the common denominator and multiply by that common denominator and simplify as you go. I find you make more mistakes using that technique. So here, part B. I'll go to blue. I look at my denominators. This one would be over 1. We have no numbers other than 1, so that's good. Then secondly, we look at our variables. We have an x squared, so this one needs an x, this one needs an x squared, and you would have 5x over x squared plus 6 over x squared equals x squared over x squared. We got our common denominator. Now we can multiply by x squared, and that will cancel out all of our denominators. What are we left with now? We didn't get left with a grade 9 question. We didn't get left.
Wouldn't the answer be 6x squared?
Oh yes, thank you. I just totally lost my 6. We didn't get left with a grade 9 question. We didn't get left with a grade 10 question. We're still left with a grade 11 question. What kind of equation is this? Do you know what they're called when they have an x squared? We learned them this year. Starts with a Q, rhymes with quadratic. Quadratic. Fascinating. Good. This is a quadratic equation. How do we solve quadratic equations? We make one side equal to 0. I'm going to move everything over to the 6x squared side. Again, I'm trying to double check my work each time I make a move because I already made one mistake when I didn't double check. And then how do we solve this? Either quadratic formula or factoring. Okay? If you're feeling confident in your factoring skills, go to factoring. If you look at this one and go, ooh, I don't like that 6x squared in front, this one looks complicated to me, then go to quadratic formula. All right? So choose one, try some things. I'm going to see if I can factor. I'm going to do some mental math here. Yeah, I think I got it. So what I thought of for the 6's was 2 and 3. And then I also thought of the other 6 as 2 and 3. And 2 and 3's put together can give me 9 and 4. And 9 and 4 seems to make 5. So my inside is 9x, my outside is 4x. I need a negative 5x, so I would want negative 9x plus 4x. But I had to do a bunch like I was doing 6 and 1, 1 and 6. You're doing a lot of mental math in your head, figuring out what are the numbers that are going to make your outside and your inside. And when I saw 9 and 4, I thought possibly that could work to give me 5. Now, after I write it out, I multiply it out in my head. I'm pretty certain that the 2 and the 3x gives me 6x squared. And then the 3 and the 2, though, at the end, I want to double check, do I get a minus 6? Yes, because I have a minus 3 and a plus 2. That's one thing I'm wanting to make sure that I check. And do I still get a minus 5? Minus 9x plus 4x, yes, gives me minus 5. So, we double checked it, factoring worked. Again, quadratic formula would give you the exact same answer. But now, why do we factor? We factor because now we've changed it to multiplying. Two things that multiply to equal 0. Either the first one is 0. And if this is equal to 0, now, I never write this, but this is what's in my head. 2x minus 3 is 0. I just write what x would be, because it's easy mental math to move the 3 over, positive 3, divide by 2, 3 over 2. This one too, if this is equal to 0, well, I move that 2 over and divide by 3, I would get negative 2/3. The last thing we have to do is list our non-permissible values and do the check. Were we ever dividing in this question? Yes, we were dividing by x and x squared. So what's our non-permissible value? X cannot equal 0. Is that one of our answers? No. Both of these answers then have been checked. They are both correct answers. So I would like you to try now 3, 4, 5, and 8. Take about 5 minutes to practice some of these.